Okay, so good day, future electrical engineers, viewers. Uh, Welcome to this discussion. So, we are going to discuss in this video the different type of alternator testing. So, which is very important topic. Okay, so first is resistance test on alternator. So, in this test, it is used to determine the resistance of the alternator windings per piece. So we all know that it has two windings, major windings, which is the armature winding and the field windings. At these times, we are going to, in this test, we are going to identify or determine the resistance of the alternator windings. So with the field winding or the DC field winding open, measure the DC resistance between each pair of terminals. Okay, so the average of the three sets of resistance, the values is called RT, no? RT. So take note that we are going to measure the DC resistance between pair of terminals. So that means DC resistance, no? And since we are having an alternator which is AC output, so that means there is a certain factor that we need to consider no? In measuring or in having the test and actual. No? Okay, so as you can see here, this is the schematic diagram for Y connected windings. No? So RP here, RP is equal to one half of the RT. So that means that if you're going to solve for RT, so yun that is twice of the RP. So it's very obvious that if you connect an ohmmeter here, this line, this line, it is very obvious that RP, example, this is RP1 and this is RP2. So RP1 and RP2 are connected in series. So multiply it by 2. So that is why your RP will be divided by 2. Okay. So now, let's proceed to the other configuration of winding, which is delta configuration or delta connected windings. So in this diagram, we all notice that the sample this is RP1 and RP2 and RP3. Okay, so as you can see, RP1 and RP2 are connected in series. So that's why this is 2P, no? 2RP rather. So 2RP, and then it is connected in parallel with uh, the third RP, no? So to get the resistance, so product over the sum, product over the sum. So it will come up with this one. Okay, so RP, so the RP is equal to 3 halves of the R. No? Okay, so take note that we are measuring this resistance, and the current that is flowing here is not actually DC, no? But that is AC. No? So meaning, let's take note that in practice, it is customary to multiply the DC resistance, which is measured here, this one, by a factor of 1.25 to 1.75 to obtain value more nearly equal to the armature resistance which carries alternating current. Okay? So take note ng that the current which is flowing in the armature windings are in alternating current. No? So alternating current, so let's multiply factor of approximately 1.25 to 1.75. Okay, so the second type of test in armature or the alternator is one. Uh, Open circuit test and short circuit test. So this is very known or familiar to us since we already tackled this one in subject uh, electrical apparatus and circuit devices. So which is performed in the transformer. No? Okay, so let's start with this one. So these tests are performed in the synchronous machine to find out the synchronous impedance for a large machine and to determine the voltage regulation. Okay? So voltage regulation, that is the main purpose, right? So first, we're going to discuss the open circuit test. So in the open circuit test, the alternator is run at rated synchronous speed. No? Take note that the alternator is being run at asynchronous speed, and the load terminal are kept open. Okay, so open circuited. So that is all the load are disconnected. Okay, so disconnected ang load, so at no load na rin siya. So the field current is set to zero. So zero lang on sa okay, the field current, so DC. Yeah? So adjusted to zero. This condition is called open circuit test condition. Okay, so as you can see in the diagram, okay, so this is supply. Okay, this is supply. So in this symbol, uh, this represent that this supply can be adjusted. No? Okay, you can adjust, and then according to the definition, the field current is set to zero. So zero lang una. At first, zero lang usa. No, ang imong kani field windings. The field current is actually increased in steps. Okay, so i-adjust na dire ang field windings, the field current. And the terminal voltage ET is measured at, okay, so VT is measured at each step, no? And then the excitation current may be increased by 25% more than the rated voltage of the alternator. So more than 25%. Take note that. So the current of the alternator is adjusted. First zero usa, and then you slowly you rotate the adjuster, no? Until such time that it will reach the maximum limit, no? Which is beyond the rated voltage, which is 25% more. Okay, so the graph is plotted between the open circuit test EP and the field excitation current IF. Okay, so this is IF. So, dira. So, you want to control so that the magnetic flux will be also varying. No? Okay, so by that, um, the output of the alternator will also vary. Okay, so it is performed. Okay, so in this way, you can identify if ever the load is connected to the terminal of the alternator. You will identify what is the voltage regulation. No? So once it is removed, then it will go back to 25 more than 25% more than the rated the no load voltage, right? Okay, next is this one. As I've said, we have two difference here. So with the armature winding circuit open, so this is the continuation. The alternator is operated at synchronous speed. Okay, it is run at synchronous speed. The field is adjusted so that AC voltage in between any pair of terminals is a little above, no, a little above 25% ha, minute. 25%, little above the alternator. And then record everything so that it will be documented. Okay, so here, this is the schematic diagram, EOC. Okay, so this is open circuited voltage per phase. And then once you adjust the field windings current, so you are going to measure. You are going to measure certain um, amount of current pila ang iyahang output. Okay? Then until such time that little above na siya sa line voltage. Okay, so in this way, in this Y configuration, you will have an open circuit value voltage which is equal to V divided square root of V. No? So this is ang V here is the reading, voltmeter reading. No? So voltmeter reading. And here in the delta configuration, so your AOC is the same as the B. Huh? So as you can see here, nakaparallel lang na siya. Ano? Okay, so nakaparallel man, so they have the same amount of voltage. Okay, so there. Okay, so recall that V is equal to is the AC voltmeter reading during the test, line to line siya. And then AOC is the open circuit voltage per phase, or that is the voltage generated in the windings per phase. Okay, so here we can identify correctly what is the generated or induced EMF per phase in this form, in this problem. Okay, so let's proceed to short circuit test on alternator. So short circuit test is performed, okay, when shorted through three ammeters. No, the armature terminals are shorted through three ammeters. Okay, so reminders care should be taken performing this test, and the field current should first decrease to zero. Okay, so field current, balik na po, decrease to zero before starting the alternator. Each ammeter should have range greater than the full rated value. So check the nameplate first before measuring. And then that data, so you need to take note the data so that you can set your meter to the highest range, no? Greater than the full rated value. The alternator runs at synchronous speed. Then the current gradually increase in step, and the current armature current is measured each step. No? So That is the short circuit test. Kung i-short ang linya, this is how. Okay, so you have DC supply, so controller, as a controller. And then at first, i-zero nimo ang imong IF. Okay, and slowly step, no? Slowly adjust. And then every adjustment, take note the ammeter, no? Ammeter. So, short-circuited ang yung linya, ito naka-linya here. And then, in between niya, the ammeter. Okay, so in every step of the field current adjustment, okay, so take note na yan kasi mo data. So here we have short circuit current which is equal to I is C, no? The same also here and here. Okay, so the field current may be increased to get armature current up to 150%, no? So that is 150%. Ganina, 25% of the full load ang iya mo increase. At this time, get current up to 150% of the rated value. No? So, rated value. So, the field current, if IF, and the average of 3 ammeters reading each step is taken. So, this one, armature current, IA, and then field current IF, then you have the short circuit test. Okay? Characteristics. So a graph is plotted between the armature current IA and the field current IF. So the characteristics obtained is called monetary short circuit characteristics. So the characteristic is a straight line as shown and in the figure. Okay. So here, short circuit test is usa lang ka ammeter ang gimbutang diri. Okay? So to find the short circuit test in a Y configuration, so IEC is equal to IE only, no? What is the reading? No? This is the reading of the ammeter. This is also the reading of the ammeter, which is divided by square root of 3 for delta. So, as you can see here, the short niya siya. Yeah, short po na siya. Short po na siya. Short po na siya. Short na. Short. So, based on the problem, you need to have an ammeter per line. Ha? So, yung makita po diha kung pila ang iyang increase ng current. Right? So, alternator parameters derived from open circuit and short circuit test results. So, we have the first formula. The main purpose is to find what is the alternator impedance. No? So, the alternator impedance is equal to what is the EOC or the open circuit voltage divided by the IEC. That is your ZP. Where XP, now X sub P is equal to the square root of ZP squared minus RP squared. Okay, so take note that XP is the inductive reactance of the winding and then ZP is the impedance or synchronous impedance in the field winding or in the winding. Alright? Okay, so okay, that's all for this video. Okay, I hope you learned something. God bless future electrical engineers.